All right, guys, we're now shifting a parabola. So we're shifting y equals x squared to any parabola. So we're adjusting it. So I want you guys to remember that we've looked at this. The completed square form of a parabola gives us that. You can actually write it like this one. I'm not a huge fan of that. But with this one, you've got a outside of x minus h all squared plus k, where hk is the vertex of the parabola. The a could be 1 if it's a monic, but it could also be another number. But we don't really care at the moment because all we're trying to do is find the vertex. So we know it's shifted right h amount of units and k and up k units. So let's have a look at this. We have y equals x squared minus 4x plus 5. Now it has said the first step is we're going to complete the quadratic, complete the square. So we've got y equals x squared minus 4x. Remember, we take the coefficient of the x and we halve it and square it. So halving that would be minus 2, squaring that would be 4. So we add that and then also subtract it. And that way you've basically added none. But what we have done is we have completed the square, which will give us x minus 2 all squared, and minus 4 plus 5 gives us plus 1. So that gives us our new equation, and it's in the form of y equals a outside of x minus h all squared plus k. And to read the vertex off is because all we really need to do is get the vertex now, is we've got h equals 2 and k equals 1 in this particular case, which means I have a vertex of 2, 1. So that's really cool. I can now look at that and go, all right, 2, 1, there is my vertex. Excellent. So my parabola was there. That's my y equals x squared. And I've now shifted it across. So what we need to do is have a look at that and we go, okay, so y equals x squared has been shifted right by 2 and up by 1. So that's why my vertex has moved to where it is. So that means my range, because we need to state its range is going to be y is greater than or equal to 1. And now, if I subbed in to find out what my x-intercept would be, I could have a look and go, well, I know my x-intercept is 5. So that one and that one, and there you go. With the second one, question B, y equals minus 2x squared minus 4x. You can, and what will probably be easiest is, I don't like the fact that we're stuck with that, so let's divide everything by 2 to make it monic and make it easier. In fact, we'll actually divide it by minus 2. So I end up with minus y over 2 equals x squared plus 2x. Got it? That will just make it easier because now I can complete the square really easily. So I've still got minus y over 2 equals x squared, halve it and square it, plus 2x plus 1. And then I've got to subtract the 1 as well just to balance out that equation. So I've now added nothing to it, which means I have minus y over 2 equals x plus 1 all squared minus 1. And then I can just bring that minus 2 back over. So I've got y equals minus 2 outside of x plus 2 squared plus 2. Okay. Hopefully that makes sense. I've done that. I've brought the minus 2 over just to make it easier to complete the square because I've got a monic, and then I've just had to bring it back over, so I've got y equals again. So I've now got it in that form, which will tell me that y equals minus 2x squared, because that was that's what we've got there, has been shifted left 1 and up 2. So if I have a look, I've got, oh, did I put a 2 in there? 1, thank you. I wondered why I was looking at it weird. So I've got the 1 there, so it's left, and up 2. So that means my h is -1 and my k is 2. So my vertex is -1, 2, which is that point just there. Now, it should recognize that we've got that, so it is a concave down graph. So my normal one would have been there, but we've shifted up to here. And if you have a look and work out what the roots of the equation are, you can sort of see that it's going to have to go through -2. So our equation, oh, that's terrible, is looking a lot like that. And there you go. That's those two done.